Ah, there we go. Yes, we have sound. Matt Sahil, can you hear me okay? All right. I think you might still be muted. I'm going to just do a quick intro.
I'm muted. Yeah, good now.
All right. Here we go. No sound. The sound should be coming in any moment now. No rip audio, no audio. Yep, it'll be fixed. I still don't know how to operate a mute button. All right, we got audio. Good. Okay, so today, super excited to share. We have two special guests joining us today. Matt Shumer, co-founder and CEO of HyperWrite AI, and the author creator of the most recently dropped amazing open source open weights model Reflection 70B. We also have Sahil Chowdhury from Glaive. He is the founder of Glaive, who was pivotal in helping get this model to everybody. So very excited to talk to you both. Thank you so much for joining me today. Cannot wait to hear more about what went into this model. But welcome to the stream, guys.
Thanks for having us.
All right. So first, let's just talk about what happened. So yesterday, actually, I'm going to share your Twitter post. Let's see. You probably posted a ton of stuff since yesterday.
Too much.
Cool. Here's the announcement. So Matt Shumer yesterday, 11:51 a.m. I'm excited to announce Reflection 70B, the world's top open source model, trained using a new technique, reflection tuning. We'll talk about what that is today, and it is doing incredibly well. If you look at the benchmarks, just across the board, competitive with the other frontier, both closed source and open source models, beating Llama 3.1405B, the larger one. And according to Matt, we have the 405B model coming out next week. So first, Matt, maybe just tell us a little bit about yourself. What do you do, and what made you want to create this model?
Yeah, so high level on myself and the company, right? So I've been personally starting companies since I was 12. We can skip a lot of time. A few years ago, when I was in college, I started Other Side AI, which is the company that sort of became HyperWrite, right? And the idea behind HyperWrite initially was, can we create an AI that can write your emails for you? We were actually the first that we're aware of VC-backed company in the sort of like quote unquote generative AI space that used the OpenAI models at the beginning. We've grown quite a bit since then. Now we have, well, a few million users, millions in revenue. We're profitable. Um, for a much sort of like expanded version of that product, it's sort of writing in general. We're the best AI for writing, continues to get better. We have a lot of sort of specific things we do, but that's the high level. In terms of this model, this is sort of just a fun thing. Very long story short, I was actually on vacation and my mind was just everywhere. And I was like, okay, I'm kind of bored of this. I need to actually do something productive. And I've been noodling on this idea for a very long time, and it was sort of like time to just do it. So towards the end of the trip, I actually reached out to Sahil and I was like, can we collaborate? And that's how this came to be.
How long ago was that?
3 weeks, I think, something of
So,
that sort.
so to be clear, you had the idea, reached out to Sahil, put together the data set, fine tuned the model, and published it all within 3 weeks.
Yes.
Uh,
And I know that sounds crazy. I get that. But I think a lot of people underestimate what can be done today with a very small amount of resources, right? Too many people look to the big AI labs and they're like, hey, look, they spend billions of dollars doing this. There's no hope for anybody to compete with a small budget and small team, small amount of time, right? But Sahil and I did this on the side, right? This wasn't even sort of our major focus, not even close to it. And it's just thinking about the problem in a different way, right? The data set was everything for this, and Glaive made that possible. We just had to kind of know what we were going after. And once we sort of had the idea of what this would look like, it was very easy to actually put into practice.
Awesome. And on that note, Sahil, please tell us about yourself. Tell us about what Glaive does.
Yeah, yeah, kind of similar to Matt. I've been doing startups, specifically AI startups, for a few years now. Just before starting Glaive, I worked at a company called Banana, where we were building serverless GPUs for machine learning. Realized that people cannot host custom models because to have really high-performing custom models that are use case specific, you need high-quality data, and companies lack that most of the times. And that is when I decided to just be a founder and start Glaive. And Glaive is essentially a platform where companies can build use case specific data sets using our synthetic data generation pipeline and train models on that and basically keep iterating on them because it's as I think Matt said, it's pretty quick to iterate on data sets with the help of synthetic data. The generation process is pretty quick. Yeah, uh, that's summary.
Cool. So, I mean, Matt, you said it. The data set is everything, but I want to touch on that a little bit because we can talk about, publicly available data and how that is essentially all used in current frontier models. And there's really like two solutions to that. You either create synthetic data or you do more with the data that you have. And so, which approach did you take with reflection, and what makes reflection special? What is the secret sauce there?
Yeah, so I think Sahil could probably talk more to the specifics of the data side and how the data set was constructed. I can talk more to the sort of idea behind reflection and why it works. So at a high level, right, the general idea is LLMs are sort of getting to the point where they can think, quote unquote think, and it's sort of mirrored after how a human thinks, right? You kind of talk through it in your head. Some people do it differently, but some people kind of talk through the problem in their head and arrive at an answer. And LLMs do that today with chain of thought. That's how they have, it's one of the reasons they've improved in performance so much over the last few years. It's been a cornerstone of pretty much every major LLM, whether it's coding, whether it's just general reasoning or writing even. So we do a lot of work with that. And one of the things that I've realized is like, look, as a person, I can think through a problem, but I'm not always going to get every little bit right. And what happens if I get something wrong? Well, personally, I reflect and I'm like, wait, I made a mistake. I backtrack and I fix myself. But an LLM doesn't do that. One of the things we noticed is that LLMs, once they make that first mistake, they kind of accept it as fact, right? If I'm asking it 2 plus 2 and then multiply that by 7, right? And it says, okay, I'll do that. Let's start with 2 plus 2. That equals 5. And then 5 times 7, right? It's already made that mistake and it's just assuming the thing that it said is right. And if we could essentially teach the model to think more like we do and actually reflect on behavior that it makes a mistake in, the model gets smarter. It gets more reliable. It gets more accurate. So that's generally the idea here. And we did a lot of, even beyond the data, it's how we trained the model, right? We created what we call like our own splitting strategy that allows the model to not learn to make mistakes, because if you do this wrong, it's very easy to teach the model to make more mistakes and then fix them. The idea is to keep the model's performance as is or make it even better. And then on the things where it actually ends up making a mistake, and it would no matter what, we can fix that. And it's still not perfect. It's still very early. It's still the first version of this, but I think we've come quite a bit away in a few weeks. So that's sort of like how it works. Sahil, maybe you want to talk a little bit more to the data generation process itself, because that was all you.
Yeah, I can do that. Surprisingly, the data set we use for this isn't that big to what people would expect. It's roughly we generated it in steps. We started out with I think just 10,000 samples to see if this is actually possible, and we scaled up to 100,000 samples. We decided that we'll do some code data, some math data, general reasoning, function calling, and multi-turn. So the goal really wasn't to get a lot of data and teach the model how to reason, but it was essentially to teach the model to recognize its own mistake. And I think to that point, see a lot of people mention that you can kind of get similar gains out of just prompting regular instruct models to use reflection. And I think that's true to some extent. You can get a percentage of the gains by just prompting. But if you try to prompt even Sonnet 3.5, for example, you'll see that there's a lot of bias in the model outputs where the model almost always believes that what it's saying is correct. And we face that problem in data generation as well, right? Like we use language models, we use fine-tuned language models to generate synthetic data. And when we first tried to actually generate reflection data, we realized that if we ask the model to actually make the mistake and then reflect on it, models are really bad at doing that. Maybe it's just RLHF if you do that. Like the models will make mistakes easily, but if you ask the model to deliberately make a mistake, it just won't be able to. And that was the main goal of just fine tuning, right? To teach the model that it can actually make mistakes and correct that.
Yeah, I have so many questions about this. So, for those of you watching, maybe this is a good way to break it down. You effectively took really kind of sophisticated prompt engineering strategies, stuff, even something as simple as explain your reasoning step by step, which is something that I put into all of my prompts when I'm giving it more complex reasoning and logic questions. But you can get obviously even more sophisticated than that, chain of thought, and so on. And so you've taken that and you've built it into the model itself, and you've actually given it examples of making mistakes along the way. And that's actually what I'm showing, I believe, on the screen right here. Actually, there's a lot going on. Hopefully y'all can see it. But effectively, you're teaching the model in the fine-tuning data itself to think through everything, more step by step, but also to, and hence the name, reflect on the output as it's doing the inference, and then potentially correct itself during the inference process. So first of all, what was the trigger for thinking that this would be really a good strategy? And then why is it better than simply having a system message with some of this prompting techniques or putting it in the prompt itself?
Yeah, I mean, why don't I start with what you just asked the last question? Sahil covered a little bit of this. Some of my personal findings with this, because I've been prompt engineering for too many years now, like basically since 2019 with GPT-2. What I found was essentially if you asked it to do this and didn't train on it, a couple things would happen. Sometimes it was sort of like what Sahil was talking about, where the model was overconfident. But there was another issue I found, which is sometimes this is kind of getting a little weird. The model would actually deliberately make mistakes that it wouldn't have made otherwise, because when you're prompting, it really wants to follow those instructions. It really wants to follow that system prompt. And if you say, when you make a mistake, fix it with a reflection tag, you're going to notice that it's going to make that mistake. What you notice with our model is that it doesn't always use reflection. It only uses it when it really thinks it needs to. Sometimes a little bit too much, but we're much more towards the end of like, use it when you need to, don't when you don't. Because if you're teaching it to do it all the time, right, it's just going to make mistakes deliberately. So yeah, it doesn't really work for prompting. And I do have to apologize. Like I said, I've not slept in 2 days. So what was the first part of your question?
No, I'm trying to understand like what the reasoning is, like what if it's better to put the prompt in the actual fine-tuned data, or if it's better to do it afterwards. And obviously, like your model is crushing the benchmark, so you've done something really well. But like, what was that idea that made you think that it's actually like let's push this to the fine-tune itself?
Yeah, I mean, I've had this idea, like I mentioned, for many months now in different forms of it. So it was sort of like, how do you enable that for everyone without them needing to figure it out themselves? But even if they wanted to figure it out themselves, without a fine tune, it doesn't work super well. Prompting, like Sahil said, can get you a marginal gain. Like you definitely will see better performance, but it's not going to be the performance jump we saw. I mean, we saw 10+% jumps in many benchmarks. I mean, it was taking almost 70B and bringing it past 4 or 5B and much further beyond that. I mean, what we're expecting to see with 4 or 5B is going to be hopefully insane. So yeah, it's really that this can't be done with prompting alone if you really want to get the full force of it. This is closer to how people think. I think there are many more gains we can make there. And it was just one of those stupid, obvious ideas that no one really thought to do. Right? I think a lot of the major labs, they're way too in the weeds in many ways. They're thinking too technically and too intelligently about this, where sometimes the simple thing is what actually is going to work. Right? Just like so many people back in, 2018, whatever, they were working on all these new architectures, but scaling the one we had was the right answer.
Yeah, and Sahil, I think you mentioned like almost like telling the model to make the mistake and then showing it how to correct itself is one of the secrets to reflection. But you also said if you do that too much, it will just start making mistakes. What is that balance? How did you discover where that kind of cliff is before it started just taking those mistakes and accepting them as truth?
Yeah, I think there's a bunch of small details there, and I think next week when we put out like a technical report, it's gonna help people understand that as well. But essentially, uh, if you look at the responses the model generates, you'll see in some way or another, it's not always structured, but it's gonna classify whether the problem is a hard problem, a moderate, or an easy problem. And you're gonna see that it only uses reflection and chain of thought for problems it thinks is a hard problem for itself. And that was part of the training. So we only added reflections. We classified problems as easy, moderate, and hard, and we only added reflections to the hard problems because you don't always need reflections. You don't want to teach the model to overthink. That was one part of it. And I think the second balance is we also added data samples, which are essentially just reflections, but the model reflects on something it did which was correct and just realizes that it does not need to actually course correct and it was already correct and move on with the existing chain of thought. So we try to balance it out with these type of samples, trying to cover as many edge cases as possible. I think there's still room for improvement. But it was essentially, I think someone on Twitter found out that this was V5 of the model we trained. We had like V1, 2, 3, and 4. And that's essentially what it was, training model and figuring out how to balance the data set even more.
So if we're looking at this example, I guess I'm trying to figure out. You give it a prompt and it's running inference and outputting. Is it truly able to reflect on the output as it's giving the output? Like, what does that flow look like?
Yeah, so that was actually a very intentional design decision where I think a lot of people get frustrated when they look at, and this is actually something we learned from Hyperwrite. People get frustrated when they see chain of thought. You know, some of the more power usery people, they like it, but your average user doesn't. They just want to know the answer to the question. And if they want to dive deeper, great, but they don't always want to dive deeper and they don't want to dig through amount of text, chain of thought
Mm-hmm.
text to find that answer. So this gets even worse with reflection, right? Because when it's reflecting in its output, it's like, oh my God, there's so much going on here. How do I parse through this? It's just the cognitive load is crazy. So how can we fix that? And one of the ideas we had was just separate the reasoning out, right? Especially as inference is getting faster. Look at what's going on with, for example, Grok and Cerebrus, right? Inference is going to get way, way faster. And if we can do some of the thinking up front and just sort of hide that from the user and show it optionally if they want to see it, and then spit out a perfect answer at the end, that's what is ideal for most users in most use cases. So the idea here is, right, the model will start reasoning inside sort of what we call output tags, or sorry, thinking tags. So
Mm-hmm.
it'll
And
sort of say,
that's
here,
what
I'm
we're
going to start
seeing right
thinking.
here.
Yeah. It's going to start thinking. It does its reflections in there. It does its chain of thought in there. It does all its planning, all that. And then it's like, okay, once it's got the right answer, or it thinks it's got the right answer, it's like, I'm done. Then it says, okay, time for an output. Here's what I'm going to show the user. And it writes the final message to the user. And I think different companies and different use cases and interfaces will use this differently. Some people will want to see it all. Some people want to make it optional. Some people want to hide it entirely. But I think that especially as models get faster and the actual sort of thinking process takes like less than a second, for example, I think this is the right approach.
And so that was the purpose of the tags, just to clarify. So you have the thinking tags. If you don't want to see the thinking, you just want the output. It's kind of like standard mode, and then you have advanced mode, and then you can actually see what's going on. Personally, I love seeing it. Like, I want to know what it's thinking, why it's thinking that, and that can actually help you kind of recraft the original prompt if you need to, because you can see if there's a misunderstanding or not. So, like, what are your thoughts on this method of self-correction during inference time versus, let's say, having multiple large language models working in collaboration, correcting each other? How does this differ?
Why not use them both? Right? Everything can build on everything.
Hell yeah. Okay.
And if you can have multiple of these models, right, thinking about different angles on each problem, and you have reflection within each model, it's just like having a better model going after a problem, but having them do it together.
Okay. Amazing. And then one last question from me, and then I know we have a bunch of questions in the chat, so hopefully, I know you have probably about 12 more minutes, so hopefully we'll get to them both. What have you seen in terms of token usage on output as compared to a non-reflection model?
Definitely more. Sahil, you might have a much better response than definitely more.
Yeah, I haven't tested out, like, I don't have exact numbers to share right now, but from just the tests I've run, it seems to be 1.5 to 2 times the number of tokens for harder problems. So it's definitely generating a lot more tokens. And yeah, I think if you're using a hosted API, that causes the cost of the latency problem. But again, I think as Matt said, Inference is going to get much faster and cheaper. So we're kind of betting on that as well.
All right. Thank you. So we got a bunch of questions already. We're using a new streaming software. I'm not sure how to put it on the screen, so I'm just going to read them. Tresor asks, will it be possible to fine-tune other models like GPT-4o Mini to implement the reflection approach? So basically, does this data set, does this approach work across the board?
It should. There will be constraints with closed provider fine-tunings because they often have their own limits on how you can actually do the fine-tuning. So we'll go into this in more detail when we release a report, and we I think are going to be releasing the data set. We're still making a final decision there, but it's likely going to be a yes. It has to be trained in a very specific way. It's a very simple training process. It's straight up just like standard fine-tuning, right? There's no RLHF going on, none of that. But the way the data is sort of split up, it's to sort of like enable it to not learn to make extra mistakes, but learn to correct them. So for any open source model, it should be doable and relatively easy compared to some of the other approaches people have put forward. For things like fine-tuning OpenAI, maybe it's possible, especially if you're creative about it. I haven't fine-tuned on the OpenAI API in a while, but from what I remember, it would be a little bit limiting for something like this.
Yeah, and I like what you said earlier. This was just an overlooked strategy. Like it's maybe it was too simple. That's not to be pejorative at all. It's like,
but it is.
Sometimes it's just like, hey, it's right in front of you. Here's a great strategy you can use. So Yash asks, what about an 8B version? And we know you mentioned the 405B is coming out. What about an 8B version that more people can run maybe locally?
Yeah, I mean, we found, and to be fair, we trained the 8B first, but we found that it made some big improvements in certain benchmarks, but others it really didn't. And 8B, we weren't really sure where some of the gains were coming from. It felt like it was a little too dumb to pick up on this perfectly. Like the 70B definitely sort of like crossed a threshold where it was like able to grok this to some extent. But given the sort of crazy interest we've seen, like we expected this to do well. We didn't expect it to do this well. Like it's been the craziest launch of my life. Given that, I think there probably is enough interest to figure out something there. But you said before, right? There are many things that are sort of like these low-hanging fruit things that people just don't pay attention to. And we have a few other ideas in mind that I think could do far better than reflection. So I think it's a question of, do we want to focus more on reflection and really optimizing an 8B that may be obsolete soon, or really going crazy and focusing on something that could actually top this by a good bit? And I think I'm more excited about the latter. But
I was just about to ask you that, Matt. Sorry to cut you off. I was just about to ask if you have any kind of new ideas going on. Do you want to hint at anything, or not quite yet?
I think if you look at my past work and you think about this from the perspective of like, look, some of the learnings we've gotten from prompting have not been properly thought about in terms of training them into the model. I think you can kind of see where I'm going with this. There are a few different ideas that I'm kind of toying with and we're talking about right now. And I think the interesting thing is with Glaive, like they're not going to be so hard to implement. They actually might be even easier than reflection. They can be combined with reflection. But yeah, I think it's the idea of like, we're going to start exploring what it looks like to take these things that make it better from a prompting perspective, and can you make it much better by training on that? How do you give everyone the power of like the world-class prompt engineering sort of stuff? baked into the model and even go beyond that. That's kind of how I'm
Yeah,
thinking about it.
that's great. And Victor asked, kind of as an extension of that, are you going to provide the data sets publicly so other people can maybe manicure them as they see fit and roll their own?
I think it's highly likely, Sahil, if you have different feelings, that we can figure that out.
No, I think in the past, like most of the open source work we have done has always included data sets. We are essentially a data set company, so it makes sense. Plus, it just makes it really easy for people to reproduce the benchmarks, the technique. So overall, I think it would make sense to open source once we have the 405B trained as well.
Awesome. Mark Cox asks, how exactly does it recognize a quote unquote mistake that requires a reflection? And actually, I have even kind of a follow up to that. Does it always output a reflection? Is it always necessary?
No. So in the dataset, we only have reflections as part of samples where the model is likely to make mistakes, and we decided that by just classifying the problem as hard. So if you just ask simple question, it won't add a reflection tag. If the question is really simple, it won't even do chain of thought and just answer pretty straightforwardly. So model can almost infer the difficulty of a problem and decide when to do reflections. But we've tried to train the model to do reflections whenever it makes it solves a hard problem and it encounters a step where it's making a hard chain of thought step. So even if you have a really complicated problem, there will be like a few steps within that problem that the model is more likely to make mistakes, and we have added reflections in the data set right at that step. So whenever it makes, for example, it does arithmetic, it's more likely to just use a reflection tag right after that and see if what it did was correct or not.
Okay, great. Alex Volkov asks, any gut feeling about using MOE, mixture of experts, and this technique? Maybe if some experts are trained like this and others aren't.
First of all, hi, Alex. I don't know. I don't see why it would be much different. I've had poorer experiences training on mixture of experts models just generally. Sahil, I don't know if you found the same.
Yeah. I mean, one benefit could be that if there's an inference speed trade-off, because MOEs are usually faster to inference, that could be a benefit. Intuitively, I don't think we would see any performance gain relative to just these dense models. But again, I never tried this, so I'm unsure.
Okay.
But people will be able to try it next week, especially if we have the data out. So hopefully
Awesome.
everyone does.
Yeah, I mean, once you do that, I'm sure everybody wants to get their hands on it, try experiment with their own techniques built on top of what you've done with reflection. So, and then actually another one from Alex, effects on quantization of this. And Matt, we were talking about this earlier. I'm planning on running it through my full LLM test suite, and I want to download it. I have 2 RTX A6000s. Maybe that was enough for, I think you said FP8. But how do you see quantization affecting the quality of the output using this technique?
I don't know for sure. I do suspect, especially from my limited testing of like, there's already an API that's up that is FP8. I do suspect there's definitely a performance loss. I just don't know how much it is, right? Maybe it's 1% and it really doesn't matter. Maybe it is more than that. I do think from what I saw at a minimum, it is much less consistent. I did notice that. I just haven't spent enough time with it personally.
Okay. Daniel Ranger is asking about context length. Is there a reason why the context length is 4K instead of 128K? And I guess, how have you seen, maybe that's not the case based on your reaction. How have you seen context length affect the performance of the model? And maybe you could just clarify what the context length is.
It should be the full
I
llama, I believe one. Go ahead. Go ahead.
Yeah, so it's the full llama context length. I think 128K, around that. I just caveat that we haven't included data that's very long context in the training, so we don't know how the performance will be on very long context, and that's something to improve on in the future. But you can essentially run it through the entire context length of Llama 3.1.
Awesome. Okay, I know you guys got to go in like 2 minutes, so I'll just wrap it up quickly. Your post got 2.2 million views. Matt, we have 1,700 plus viewers in here and growing. It keeps going up. So I think there's a lot of appreciation for what you've done, and you as well, Sahil. I just want to say thank you, especially like from the open source community. I love seeing open source compete with closed source frontier models. It makes me so happy that I can download this stuff and play with it myself. So thank you so much. If you want to check out Matt, here's his Twitter right here, Matt Shumer _ and he is the CEO and founder of Hyperwrite. So check out Hyperwrite AI. And all of this was built with Sahil's company. Founder of Glaive, Glaive. So glaive.ai, I believe it is. Is that right, Sahil?
Yeah, that's correct.
Yeah. So if you have a novel approach, just like Matt did, contact Sahil at Glaive and you can make it happen. And I just want to say thank you both. I mean, this was like a last minute thing. You just pinged me, Matt, and I was so happy you agreed to join. You too, Sahil. So thank you so much. Thanks to everybody who joined. And I'm glad we got some details.
Yeah, thank you for having us, and thank you for the support.
All right. You know where to find them. We'll drop it all in the description.